Welcome to the folks currently joining in. We're just waiting maybe another minute or two. And it's a pretty packed session. I think my idea is, so it's already the fourth one, so I'm not sure that we want to test the patience of everybody to do a fifth session. Obviously, if we need more time, I think that's what we'll do. But if we can fit within this time frame, then that'll be good. And as usual, it's it's not the last time that we hear from those topics. It's just a way for you to present so that everybody can be aware of your attempt and hopefully find synergy between the different companies and folks interested. And then typically that gets discussed further in SIG groups where the actual action is happening. But that's just a great way to kickstart the effort and hopefully see some synergies between folks.
Awesome. So I think we're a couple of minutes over. It's time to start. Do I see Burhan here? If not, we can just, I see Stefan is ready to present, so we can, okay. Seems like Burhan is just joining. Great. Burhan, can you hear me? Am I saying your name right?
Yes, hello. Yes, I can hear you.
Awesome.
That's
great.
right.
Thank you so much for joining. I think we're just starting right now. Alex just set the stage that we have a little less than 15 minutes. We have quite a packed agenda. So if you can start sharing your screen. I hope you're a co-host. And we
just
should be
made
able
him
to
a co-host.
Excellent, excellent, excellent. So, and I believe you're going to talk about the tokenizer proposal, right?
Yes, exactly.
Awesome.
I'm just getting the permissions to share. Actually, I have to close Zoom and reconnect. I will do this quickly.
The joy of having a Mac, I think.
Hello. So I'm back. Actually, okay. Yes.
I made you a co-host, so you should be able to present. And yes, we see your screen.
Okay, perfect.
Awesome. Yep. So we can see your screen. If you can make it full screen, great.
Yes.
Please go ahead.
Okay. So I will be presenting my idea. Actually, it's for an added support for the transformers to the ONNX library. So actually, the idea is about the tokenizer support. I will just describe briefly how the user interacts with ONNX today and how we wish it to be. So as a beginning, let's say we have a large language model or any transformer architecture, and we want to adapt it using the Hugging Face library. So at first, we will use traditionally the datasets library to load our inputs. Then we will tokenize our inputs using the tokenizers library also provided by Hugging Face. And then at the final step, we would load the model using the transformers library also provided by Hugging Face. Then we would be able to do our inferences and get our prediction. So that's how it goes actually today using Hugging Face's interface. But if we wanted to implement ONNX, and I should mention the need to implement ONNX in this case, which comes from the enhanced inference time. So actually, as I am a consultant at IBM, we are using this ONNX models extraction in order to bypass the minimum requirements for a function to be able to be called. Because like in deployment environment, we need a model to be the fastest possible. So in order to enhance our inference time and hence reduce it, we are using the ONNX extraction of the model. So in comparison with the previous architecture, we jump from using the transformers library of Hugging Face to the ONNX library by extracting this model as ONNX format. And then we use ONNX runtime to do this inference and get our prediction. This is possible to be done today and is giving us very important results because we are able now to enhance our inference time. However, this always requires us to have the tokenizers library installed, and hence we are always dependent on the Hugging Face library. And this is actually posing a bit of a problem for us because we would like to minimize our dependencies in the development environment, in the deployment environment. So for instance, here we can say that we only need pandas, ONNX NumPy array, but also the tokenizers. And the suggestion is the following. So actually, we are suggesting that we implement this tokenizer part into the ONNX model, hence to formulate or to obtain a single entity that contains both the tokenizer and the model in the same packaging. And in this way, we would be able to do our inference in the least dependencies required possible. So in this case, we would just install our pandas library to get our inputs and then pass by ONNX runtime to do our inference. And our prediction will be received as an NumPy array, and we can cast it then as a TensorFlow or PyTorch. It depends on our environment. But the idea is that we now no longer depend on the Hugging Face library, which can ameliorate the deployment model. And in this way, we can be able to have better support for our model and also profit from the inference time reduction using ONNX. And actually, to support this proposal, I also found some GitHub issues that address exactly this idea. So I just for reference, a bit of a reference, I mentioned these 2 points on GitHub. So it's actually, they are open issues dating from 2022. So it's recent. Actually, it's the second half of 2022. So it's a recent suggestion, and not also suggestion, but people are trying to have a workaround around this to solve this and have a good implementation and minimal requirement deployment system. And also there is questions and another suggestion at the Hugging Face community that address the same problems. But actually, I guess we don't have enough time to discuss them all. So I'll just leave this as a support. And probably I'm open for questions, or if there are already some solutions on the issue, or if you are already facing the same issue.
One question is, do you know of how PyTorch or TensorFlow are handling tokenizers? How would the exporter work in those cases?
Well, in this case, we didn't go through the implementation of the tokenizers in Torch or TensorFlow. But actually, from the initial research that I had done, there is some equivalences that are being done, but they are not direct and they are not portable. So in this case, we thought that having a universal or plug and play solution would be better for reproducibility and better usage in other cases. Okay, I see Prazan, if I spelled this right.
Yeah, I was just
count.
pointing out that this is a common problem that we have as well, and others in the community. So at least on the ONNX runtime side, there's a ONNX runtime extensions library that has a bunch of custom ops that implement many of the common tokenizers. So you can take a look at that as a starting point.
Yes.
And then there's also a pre-processing and featureizers working group. And that one meets, this is an ONNX working group. It meets regularly, I think once a month, where they are looking at how to kind of standardize some of these featureizers and pre-processing tokenizers into the ONNX spec.
Yes, thank you for your input. Actually, for the first reference that I mentioned, so it's a GitHub reference, the number one. Actually, it points to the ONNX runtime extensions GitHub repo, and it's an actual issue reference there. So I thought that, and I guess this is the good place as a steering committee, that we can like start working towards that in order to portabilize this feature and not just implement it as a case-by-case usage, because like nowadays transformers are the most used models in NLP. So I guess having this support would be beneficial to all users of ONNX.
Agreed, and it's very important for portability. Like if you encapsulate all of it inside of the ONNX model, then that model can run everywhere. If there's all this tokenization that happens outside, then if you want to move to Java or C# or something, you have to rewrite all of that Python tokenization.
Okay. Actually, I didn't explore other languages because like our runtime environment is in Python currently. So I don't have enough visibility on other platforms.
It's a problem that comes up from other customers, for example, who deploy ONNX models into, let's say, Java or something.
Cool. Awesome. Thank you for your thoughts and proposal, Burhan. Are there any other questions on the bridge? I think you have a good follow-up. Essentially, Prashant is suggesting you engage with the pre and post-processing working group, right? And Rama is here too, so I think that's the right place for you to follow up. I think this is a great proposal. It's potentially needed. And thank you for driving it and bringing it to all our attention. Okay.
Well, thank you for
with that said, thank you so much, Burhan. So if there is no other questions for Burhan, let's switch over to the next presentation. Stefan, are you ready for yours? We cannot hear you yet. I think you're muted.
Yes. I am just setting up the sharing of the screen. All right.
We can see it.
You can see my screen? Great. Let me just go here and slideshow. All right. Hi, everybody. First of all, I just want to say that it's kind of an honor to be part of this steering committee. To be presenting to the steering committee. I've been at my current company at Eisen for over 2 years, and we've been really investigating and found that ONNX is one of the best solutions for us in terms of model portability, and I will show in the use case. Most recently, I became a VP engineer, but my background is in ML engineering, VP of engineering, but my background is in AI, so I know a little bit, but I also am looking forward to learn more from everybody else here. So that being said, we use ONNX a lot, and my proposal is very simple. It's adding float64 calculation and outputs to the tree ensemble regressor and the tree ensemble classifier ML ops. So these two ops right now don't have support for float64, and I will say that possibly it's for us very important, which I will get to in the use cases section. I know that from the other, I have attended the other proposals, and I see that the push is obviously towards float 8 and float 16. So I think I'm going in a little bit in the other way, and I will try to explain why that is. I am aware that I took some technical references. I won't get too much into them. If you want, You can check them out. Why this is certainly a little bit of a problem. I know that one of the persons that wrote these technical references is on this call right now. So in that case, I just want to say that it's been an honor kind of reading this and being a part of the same discussions with you guys. So it's Xavier wrote about it in the ML Predict help documentation a couple of times, depending on which case it is. And it's also in the sklearn to ONNX conversion, especially when we're trying to use models from sklearn that are decision trees, any tree-based methods. We have the same problem that arises. So the use case, which is that our company is in the regulated industry sector. We are in the life sciences manufacturing, so we are creating models to be helping the use of creating in manufacturing for pharmaceuticals and biotech companies. And so for us, obviously, one of the big topics is model portability. But more importantly than model portability, one of the big things ONNX provides us is model retrocompatibility, that there is some kind of a guarantee that between one version and another version of ONNX, the models that were created in previous versions will continue working, which is not always true with many of the other libraries that are able to create models, right? Especially in our case, as it's a regulated industry, it's not super strong on deep learning models. We deal a lot with tabular and time series data, and so there's a strong preference to traditional machine learning algorithms, and especially tree-based methods, right? So a lot of the models that we create are from scikit-learn, XGBoost, tslearn, PySpark, and obviously some of it is from PyTorch. And PyTorch ones are, as we all know, probably the easiest ones to convert. The other ones have a little bit some tricks that need to be implemented, right? So one of the biggest reasons why we want to do this, and I will go in reverse order, is because for our case, all these models that we create, we need to make sure that the precision stays consistent. So that means all the model metrics that we calculate based on the training data and the inference results need to stay the same, right? And especially for the tree-based methods, this precision can affect a lot the outcome, especially in the classifier tree-based methods. And in the regression ones, there's a margin of error. So in our industry, this margin should be non-existent. So for us, precision is more important than speed. If a model takes longer to calculate, that's okay, and that's why the use of Float64, especially if the original models were created in Float64, is super important. The same thing happens in other operators. For example, there's a linear regression operator in ONNX, which has the same problem, that it's only float32. However, in those cases, an alternate conversion is possible, as in a linear regressor is just a matrix multiplication. And in addition, both operators support float64. So instead of converting to the linear regression operator, we convert to the matmul and add, and we're able to get the exact same results. Okay? So that being said, I just wanted to see what the next steps are. If anybody here knows of any alternate directions, if we're on the right track, which SIG this would belong to, how do we contribute? So if we want to join, there's a couple of people on this call that are also working with me. If we want to contribute to this or guide the implementation of this, where do we do it for both the ONNX and the ORT? Would it be on Slack, specific people, channels, and just a little bit possibly points to more information on how ONNX and the ORT is structured and implemented, so we can start helping out. And that's it for me. So I will just stop sharing and see if there's any questions.
Mikhail or Rama, do you have any thoughts around it?
So yeah, on the ONNX side, I think it's fairly straightforward, I think, to add float 64 support to the ops. I mean, I would just suggest they can create a PR. I mean, it's a fairly simple process to add a new type to these ops. On the ONNX runtime, of course, I mean, again, it's fairly straightforward, but they should check with the ONNX runtime team because they instantiate ops for specific types somewhat carefully to avoid the binary size from increasing too much. But I think conceptually it's straightforward. Yeah.
So some additional comments. So it's Xavier. So I wrote most of the code for the tree ensemble. So right now in the offset, the version 3 of the ML offset, you have double thresholds, but float output.
Yes.
Is it enough, or do you need more?
So ideally, it's a float 64 output also, so we get the exact same inference result on both sides.
Okay, so well, yes, I guess you can. Well, it's easy to extend the types with version 4 of the offset. From ONNX runtime, well, in ONNX runtime, the code is templated, so adding a new type is not difficult. It's just a question of size, as Rama said. So,
what's the problem with the size?
Well, the developers, the core developer of ONNX runtime would like to avoid the size to grow too much. So, and the tree ensemble is a quite huge code. So every time you add a new type, you multiply the number of versions, and it's adding a lot.
Okay.
So I would say there is a way to minimize that increase by disabling some types with some flags. So at some point we should be able to add this without adding too much for some users and adding the functionality for some other users. So it's just a question of how do we do it, but it's not difficult.
Right. Xavier, so it sounds like Stefan is willing to contribute also to the effort. Yes. So in some ways that he may be able to provide some resources to help you perform this task. So that might be an ideal situation.
Yeah. Well, I'll answer your any PR you can create. And if you have any questions, just, well, you have my mail. I don't know if it's available in the invitation, but feel free to ask any question. I'll answer.
So what's the best way, via email or via Slack or?
Slack, mail is better. Slack, it's just too many social networks, and sometimes I don't follow all of them. So yeah. So
Xavier, maybe you can just post your email address on the channel here, and
yeah, I'll do that.
Thank you.
Great. Thank you. Thank you so much.
Great. I think that was great. Thank you so much for your contribution, Stefan. And let's see, who do we have next?
Ram is next, and he should be a presenter.
Awesome.
And we can see your screen.
You can see it? Okay, all right. So let's be on the safe side. Maybe I'll just use it in this current mode. So in this talk, I'm going to briefly cover issues that show up in the context of distributed inference. Recently, we have seen a trend of models becoming larger and doing inference with very large models. often requires the use of multiple GPUs simply because of the memory requirements and computational requirements. And so here I'm going to specifically focus only on the question of, can we enable an ONNX representation of a model optimized for distributed inference over a multiprocessor target? So specifically, optimizing for a particular target is a fairly challenging task, and how we do the optimization is not something I'm going to consider, but it's more, if we have an optimizer, can we enable the optimizer to be represented as an ONNX to ONNX transformer, where it can take an ONNX model and then represent the optimized model also in ONNX? And what do we need in ONNX to enable this? All right. So broadly, there are a few different design choices and questions that come up in this context. The first is that of communication ops. What kind of communication ops do we want to add to ONNX standard? And a second question is, how do we actually represent the parallelism itself? Do we introduce new ops to represent parallelism, or do we use some other mechanism? And the third issue that shows up is once we have communication, we have function ops which are not purely functional ops, as we have had so far in ONNX. So how do we represent this? And so let me go to the first issue. And so in terms of what's happening with the existing practice, existing distributed training and inference solutions rely on the use of what are called communication collectives, such as NVIDIA's Nickel. These are essentially distributed ops, such as all reduce, all gather, and so on. There are a bunch of these ops. And so one question, I guess, that comes up is, do we add such ops, these high-level ops like all reduce, all gather, which seems like a natural first step. I think it's the simplest and easiest way to support distributed inference. But from a longer-term perspective, one question that comes up is, well, do we, as more and more other collective communication ops show up, do we run into the situation of continuously having to add more and more such ops to the standard? And from that perspective, I guess having lower level primitives like a send, receive, or broadcast as a very small set of primitive ops would enable us to express far more of these ops. So specifically, I guess, keeping up with the approach we have taken in ONNX so far, a natural approach would be to basically support both of these, where ops, these higher level ops like all reduce, all gather, and so on, can be expressed as functions over these lower level primitives like send, receive, broadcast. So as a simple example, ring-based algorithms for doing an all reduce over a ring-like topology can be expressed as a function, as shown here, over a lower level primitives like send and receive. And so that's okay. That's about communication ops. So now let me switch to the second issue, which is how do we represent parallelism in the model itself? Again, there are a couple of approaches. One fairly simple approach, not requiring significant anything new, is to represent the optimized model as a collection of models, actually. Let's say one for each target processor, or a rank, as they are called typically. So for example, it could be the same model that's being run in all the processes are potentially different models for different ranks, but without anything special to support this. Another possibility is actually to introduce new parallelism ops specifically as an op. So you could, for example, introduce a parallel for op that lets you capture the same information without having to represent a collection of models. A single model can then represent the entire distributed computation. Again, here, the second approach is somewhat more general, but it also, I guess that also makes it potentially more complicated to implement, because in general, if it's introduced as a hop, it introduces far more possibilities. For example, you can use this up in a nested context, and so we need to figure out whether we really want to support all these general extensions that become possible once you make it a op, as opposed to something like in the top first approach. So, so again, here representing how things will look like. I'm writing these code fragments in Python-like syntax for simplicity, but they can be essentially represented as a ONNX graph and a model. So taking the first approach, we'd, for example, if you have a simple case where the model is a single node, actually just doing an all reduce, for example, then you have a single graph with a single node invoking the ring reduce or the reduce up, basically, and you use the same model for every target rank. But what you have down below is the more complete model where, again, you have a single node which is actually a parallel for and which has a subgraph, which is a graph attribute, similar to the control flow ops we have in ONNX. And this graph represents the computation that each rank will perform, shown here, which actually is going to invoke the reduce of, again, right. So as a quick note, I'm just, in this talk, I'm not presenting a very concrete proposal. I'm just describing some of the design issues and choices that show up just to stimulate discussion and hear back opinions on pros and cons. And so let me move on to the third issue, which is, as I said earlier, I mean, so far in ONNX, all the ops we ever had are essentially pure function-like ops without side effects, without any dependence on an external environment. But once you have communication ops, they are no longer pure functions in this spirit. So for example, we cannot reorder two communication ops in a model because it's going to have an undesirable side effect. So we need some mechanism in ONNX to deal with effectful ops, and because it's an extension now. And but I think this is fairly simple and straightforward. I don't think there's much. And I think in this case, the simplest approach is probably to simply add an annotation to the ops schema of ops to indicate that it's an effectful op, like a communication op, so that it cannot be reordered. And I think in this case, the extension is fairly straightforward, and I don't think there's much to be, not much of a complication here or difficulty in implementing. Finally, I guess there's the question of these process and processor IDs and how we type them. And again, if we want to go down the path of defining functions, have the ability to represent like this ring-based reduction algorithm as a ONNX subgraph, the simplest is to have processor ID be an integer type as opposed to, say, abstract or opaque type, and that just simplifies expressing, for example, identifying the next processor or the previous processor in a ring-like topology and so on in a fairly straightforward fashion as shown here. So yeah, I think so I'll stop at this point and yeah.
So Ram, I think we can open up for questions. I have a few, and then I'll let the others also pitch in. So the first question I had was around, what other synchronization primitives would we be needing? Like if every hardware vendor has its own implementation of a barrier call, how would that be used? Do we need that explicit primitive to be here or not?
That's a good question. And I think in terms of the existing models and what they do, I guess they don't really require synchronization primitives so far. But in the longer run, if there is a need, we would need some low-level primitive for synchronization. In this model, I mean, there is already an implicit wait introduced by send and receive, which is, I guess, already some form of synchronization. But if necessary, we could add something. But in terms of the existing models and the existing implementations, I guess that's
okay.
Need. Yeah.
I think I'll also review it with one of our experts, and then we can go into more detail. And this will be covered in the operator SIG, I'm assuming, right?
Sorry, meaning what? I mean, it's sort of, I guess, sort of spans both the operator SIG and infrastructure SIG in some sense because of the scope of things, but yeah.
Okay. Prashant, what do you suggest? Should it be in, or Alex, what do you suggest? Should it go into infrastructure SIG or is it in operator SIG?
I think it's kind of the same meeting, so that's probably okay. Either way.
Okay, all right. And my second question, Rama, is around like, would we be needing to even be explicit about the data types being used in these primitives? Or
which one are you specifically referring to? I mean, the only one place where it came up is
like all gather, right? Like for all gather, do we need to be explicit about the data type, or it doesn't matter? Is it just a raw buffer that we're just gathering?
Yes, the types will show up just like for any other op we have in ONNX. I mean, all the ops do have types, and all reduce as an op will have types. I mean, it whether it's a tensor, or float, or int64, or int32, whatever. I mean, yeah, they'll be typed. Yes.
I have a high-level questions. Some of the flavor is a little bit like MPI, so with no shared memory where you send messages, and others feel a little bit like more shared memory where you have parallel. Do you have an assumption about what the underlying hardware, like whether you have shared memory or not, or what is your basic assumption?
Yeah, well, here in this context, I'm assuming there is no shared memory. That it's message passing based.
Thank you.
I guess if there are no other questions, we're running a little low on time too. So if there are no other questions, we should probably follow up in the operator/infrastructure SIG.
I haven't
any other questions, anybody? Go ahead.
I haven't seen Jacob, who is the next speaker. So is Jacob here, or should we? Otherwise, I believe Ken is here, right?
Yeah, I can see Ken here. Ken, are you ready to present?
I'm here. Yes.
Awesome. And before you begin, let me also check if Christian is here too.
Yes, I am.
All right, great. So over to you, Ken. We're running a little low on time, so if you can walk us through quickly.
Yes. And 1 second.
You are a co-host, so you should be able to present.
Okay. Let's see. I also need to restart. Sorry about that. It's a Mac issue.
Oh, seems like Ken dropped. So maybe we should start further with this. Christian, do you want to present? If you can, then we can squeeze in Ken after you. Then.
I can try. I was just about to say I might have the same issue. So I'm going to try to share my screen and see if I also run into the same problem.
You're also a co-host, so you should be able to.
All right, seems like Ken is back.
Yeah, Ken is back, and I made him a co-host again, so he should be able to present.
Apologies for that. Okay.
And we see your screen.
Okay, perfect. So hello, everyone. Today I'm here to present two proposals by Manoj Sabral and I. So we have this intended goal of increasing sparsity exploration, especially from the community. We want to be able to expose this functionality, make it very easy for someone to just explore this and get their feet wet. So part of this, it'll be a two slide proposal. So I do want to solicit advice and feedback from anyone here, especially if you have any ideas. Okay, so the first of which is around operator attributes. So ONNX, it's very popular for model sharing due to its portability. And there is support for weight sparsity at the moment. However, we did find that it's not simple to determine whether a model is sparse or what the sparsity format was. So if it was a training aware sparse model, it may be more difficult once it's in this ONNX format to determine what it was without maybe depending on something like an ONNX runtime sparse tensor API, right? So we find this to be a little bit of a blocker. There is currently sparse tensor, but we'd like to expand upon this. So the idea is something like, we'd like there to be a sparsity attribute which can indicate the structure. So I think most of the time what we'll find that is common is unstructured, unless someone is creating a sparse model based off a certain hardware implementation. So if it's IHV specific, it might lead towards some kind of structured sparsity. However, if there is some kind of attribute, and especially if this can be seen at the graph level when someone is sharing the model and it could be seen in Netron later on, we think that'll be very beneficial. And then secondly, if it's possible or usable, a sparsity or a sparseness indicator. So let's say we have a model that has a bunch of layers that are 30% sparse or 50% sparse. At runtime, it would be helpful for the execution provider to determine whether to use it as a sparse tensor or whether to go with the dense representation based off of overhead or knowledge about the hardware capability. Of course, this can be calculated from the graph, but it might be something that would be helpful when we're just viewing the model itself. So the overall goal here would be to improve the sparsity visibility, especially since these models are shared commonly throughout the pipeline. Okay.
And Ken, keep on going.
Yep. I'll finish this part up really quickly. The second part of our proposal is to call for an exploration for there to be low effort ways to generate a sparse model. So right now we do know there's no single best sparsity format, right? That's agreed upon throughout the community. And in turn, this could turn a lot of people off from exploring this, because this does create this whole field where you don't know which one to do. You already have a trained model. You don't really want to invest a lot of time and effort into creating maybe a training aware sparse model, especially if you don't know whether your deployment hardware can benefit from this, if there's too much overhead, or even if you can get good accuracy from a very sparse model in the end. So right now, I don't see there be many turnkey solutions to see how an ONNX model, specifically an individual's model, would benefit from exploring sparsity very quickly. So for example, is there any disk-based benefits? Is it turning a sparse model or sparse matrices into dense matrices at runtime, and is that creating too much overhead, right? So there are other toolkits that offer a single line API method to be able to generate sparse model based off maybe something like a floating point threshold or percentile based. And similar to quantization, we know these low effort one API methods like dynamic quantization doesn't offer the best results. However, it's the quickest to be able to evaluate what it would look like if you generated a proper model. So this is also driven by sort of like what we explored on the first slide, but feedback that it's a little difficult to spend resources on something without knowing what the potential is. And before getting to that, we'd like to really lower the barrier for entry. So on the right-hand side, we have this little graph that has data-free sparsity, right? This could be very simple based off of like threshold or percentile. You know what the output could be like, and then you can move on to the next step, right? So you have a already pre-trained model, and you might want to see, given some data, maybe doing some kind of sensitivity analysis that I'm open to discussion, but something that offers a very simple methodology to generate a sparse ONNX model. And this is something I'd like to request for further analysis.
Makes sense. No, actually, both your proposals make sense. Do you have more material around any further things, or are these the two slides that you wanted to share?
These are the two slides.
Okay, awesome. So sorry, we're pressed on time, so I want to a little bit rush things on. So let me open up for questions. I think from my side, I understand your first proposal is primarily in the either the metadata of the model or in some shape and form standardize expressing the sparsity format and its level of sparsity. And your second is essentially you're expressing an interest to start an investigation or an exploration around it, right? And I think then your proposal would also fold into it.
Yes, that's
and
correct.
I see that Prashant suggested that there could be a sparsity working group. And that would be quite an interesting thing to the community also. And I'll leave, Rama or Mikhail or Alex, you have any further thoughts, or anybody else for that matter?
Yeah, I guess, we could also continue the discussion on as the issues in the ONNX, given the time constraints now. Yeah. I think,
okay. Yes. Right. So I think given the time, this would be a good follow-up for you, Ken, if you can maybe bring it to the operator infrastructure and propose that, this exploration be initiated and then we can go from there. Does that make sense, Prashant?
Yeah, that sounds good.
All right, sounds good. With that said, let's switch over to the next. Christian, are you ready to present?
You should be a co-host.
Yes.
And we see your screen.
Awesome. Thank you. And thank you so much, Ken, for your proposal. Sparsity is an important piece, and thank you for bringing it to our attention. I hope we see your contributions and the other through the right mechanisms. Okay, thank you.
And thank you everyone for the time.
Thank you. All right, and then I will take over. So my presentation is, so first I must apologize. There was a bit of a time mix up. This presentation was meant to actually be given last week. Well, last week this time, I suppose, as in I was 1 hour late because of summertime. So apologies, well, whatever, there was a mix up with the time. So datetime parsing in ONNX is the topic of this presentation. And here's a very short outline. So first I'm gonna talk very briefly about the use case and why we actually encounter this problem and in what space. Then drilling in a little deeper, what is actually sort of the goal we would really like to achieve with something like this, having with some kind of datetime parsing in the standard, and then a very brief survey of how existing programming languages and tools are dealing with this problem, and then a more concrete proposal. So what's the use case? So in our case, and I can only imagine in many other cases as well, datetimes are often presented as strings. They are stored in databases as strings. And we have in particular the use case that we would like to do as much as possible of the feature engineering in ONNX, just because it's faster, it's easier to archive, etc., for all the known benefits of it. And datetime parsing really, unfortunately, at the current point in time, comes up as a blocker sometimes, or rather it forces us to actually have some feature engineering or pre-feature engineering in Python to essentially just turn existing date strings into something numerical that ONNX can natively work with. And of course, that would be very, very nice to actually just bake that into our ONNX models as well. So what would we actually, or how would we like to achieve this? Because datetimes are of course a little infamous of having feature creep and turning into very complicated problems to solve. So I think it's important to outline what to do and well, also what not to do, more about that later. So really the idea is to only introduce minimal datetime capabilities to ONNX. The idea really is, okay, given some kind of string format, we want to turn it into a Unix timestamp. I put a little asterisk here. I'm going to talk about what that means in a moment. Then also, it's going to show up again in the non-goals further down. The output, as is also the standard for Unix timestamps, would always be in UTC, just so that, well, we don't have to deal with time zones. And then, of course, while there are ISO formats around datetime strings, reality is that people come up with their own formats, and I think any tool with wide adoption would need to be able to have some kind of customizability around the format string. And then very important as well is the error handling. What is happening if some of the input is actually just not fitting the expected format? And that then sort of leads me to future extensions of this. So while the initial support that would really already solve a lot of use cases would really only be parsing a datetime string into something, into a Unix timestamp, there are many other things one can think about, namely, for example, weekday, year, month, day, etc. Those operations, of course, then quickly turn into something where you have to deal with time zones again. So deliberately not part of this proposal, but something to say what could potentially be implemented in the future if we, for example, wanted to introduce a datetime domain in the ONNX standard, for example. And then to just make it explicit, sort of the non-goals of this proposal are definitely not proposing a new data type, which would exclusively serve datetime, as most other solutions, well, as most programming language libraries are actually doing it. I don't think it would be befitting, or it would be a good fit for the ONNX standard at this point. And again, dealing with time zones, at least for the minimal viable product, I think is definitely out of scope. All right, so a very quick survey, what's going on elsewhere. So the most famous one, of course, or potentially is the C standard in this regard. So C has the string p time. I've actually never pronounced it out loud, but I'm sure most people have come across this function. And of course, that function takes a formatting string with a bunch of percentage signs, etc. Python actually follows the same standard. Rust as well, or at least the one I looked at is the de facto Rust standard. It's called Chrono. So essentially, it would be a pretty reasonable choice to stick with the C standard for the format codes. And then what do the different programming languages and libraries actually do with the result type? It would be, as mentioned on the previous slide, it would not be uncommon for a normal library to really introduce a new type to hold the data time. But again, I don't think this is viable for the ONNX use case. But well, it is what libraries usually do. About error handling, so string p time returns null if the input string didn't conform to the expected standard. Python raises an exception, also not no surprise there, and Rust on the Chrono side actually returns, well, so follows the standard Rust error handling. So all of them, I guess, do pretty idiomatic things when something goes wrong. But of course, the question is how to do it in ONNX. So here would be the proposal. So it would be essentially an operator taking one input and two attributes. So the input would be a tensor of type string, and the attributes would be, the first one would be a format string. I'm sure most people have probably come across such strings. Maybe it could default to one of the ISO standards, or just didn't, or just don't. And then the other one would be a unit. Now that one, now we are sort of starting to deviate a little bit from the standard. I'm going to talk about this in a second more, because first I want to sort of take your attention to the output. While the Unix timestamp usually is an integer, I would propose that in this case, we would go with a double, just because in a double, we of course have a pretty natural way of dealing with things going wrong. Instead of crashing essentially well, not crashing the inference, but like aborting the inference, we could actually turn it into not a number, which might actually be more fitting for many use cases. But of course, for that, we would need a double, which would be a deviation from what a Unix timestamp usually is. And then, of course, one has the problem that the precision would be decreased. So depending on the use case, if one wants to go millions of years in the future or something, then maybe we would need to take a different unit. So that's why sort of there might also be a use case for having a specific unit in the attribute so that one can scale the number of return seconds. And yeah, I actually, just before the talk, I removed the summary slide, because essentially it just said questions and further steps. And this does take me to the end. And this would be the proposal. And I would be very excited to hear some thoughts about it.
Yeah, I think it's a problem that has a lot of interest also IBM. I think we also have dealt with something similar. We might have a proposal in the past, but this one seems very well structured.
Thank you.
Any questions from anybody on the forum? I think Sarah may have had to drop because of it at 10 a.m. local time for him. How fitting for this discussion. So anybody else has the questions, comments?
One minor comment is why double, why not in 64? And you say either a negative -1 or a max hint or something as a equivalent to error.
A negative -1, but then of course we would have the problem that we couldn't represent a date time prior to 1970, which definitely is something that comes up. So negative integers would, I don't think that would be a good fit for conveying the error case.
Okay. Yeah, I don't know what the precision loss in double signifies. I mean, it seems a bit strange to. I don't know how many bits of precision is required for this. So.
Yeah, I mean, for most use cases, it would be perfectly fine. Or that's too broad of a statement. I shouldn't say that. But so anything that I suppose deals around today plus minus a few hundred years will be well served with double. Probably a few thousand years.
Is there already support for some of this stuff in the ORT extensions?
Well, honestly, we have not used the extensions, and I would need to look again, but I don't think there is.
Yeah, I just took a quick look right now, but I didn't see it. But yeah, it sort of falls into the same bucket as pre-processing, general string.
But I do think it's important for the standard to come up with a standardized solution, because like extension to a specific runtime is not really the gold standard as far as, I mean, I think it's great that there's additional support, but I think that's a problem that comes often enough.
Right.
I know there's some folks at IBM that have had proposal in this region, in this area. Right. I can try to see try to find who they were and what their proposal was and put you in touch. Right. It sounds like it's probably a situation that where lots of folks that have experience in this should come up to see if the solution works for them. It seems well structured, and I like the trying to make it simple. So can you say a word? You said you would have to have special inputs or custom inputs. How does that for that? It's a custom parser. So how does that work?
Maybe this is what you're referring to. That the format is customizable. That's what I meant. Is that what you're referring to?
Yeah. So would it be defined in the standard, or you're saying that's a custom? You know, what do you mean by customizable?
That essentially the operator would take an attribute that defines the expected format. That's essentially also how the C standard does it, how Python does it, how Rust does it. So you have usually some runtime defined, let's say, some string you want to parse, and then some other string that defines the format that you expect the first string to follow.
Okay, so you don't mean to create new percents, a new letter. So it's like the set of format is well defined. It's just like each operator could be looking for specific different fields. I think that's okay. That totally makes sense.
No, sorry. I maybe I should specify. So the C standard, as far as the C standard essentially defines a bunch of these whatever year. Honestly, I'm not quite sure what percentage B stands for. This is probably day. Of how a date string, sort of where the information sort of comes from. But for the purpose of this, okay, actually, maybe this is a bad example because, well, how would this necessarily, well, in UTC, you could then, it would be interesting to see what the C standard does if you don't give a particular day, a particular hour and minute, and how it would then sort of translate into a timestamp. Maybe I should also like, what is Unix timestamp? Because like this timestamp here, like the Unix timestamp is usually number of seconds since the 1st of January 1970. Just in case that was not clear. And so the format time string just says how to extract the information in a very flexible way. And I'm not proposing coming up with a new standard for this. I'm saying we should just follow the same C standard that, well, obviously C follows, but also Python and also Rust. All of them follow the same standard already. And plenty more languages, I think, as well.
Makes total sense. So Rama, do you feel like that is something that will also go to the operator, or do you have another suggestion?
I guess this would be an operator SIG. I mean, since it's one specific operator, I guess it should be fairly straightforward as long as there is consensus on the details, like you said. I mean,
Okay, so I think the action items, Christian, I will put you in touch with some of the IBM folks so that you know, they can start a conversation, and that may give you a different data point. And if there's anybody else that is interested, I think they should reach out to you to see if that cover really all the use cases that they have seen in their own experience. And then I think the next step would be to make so either a presentation on an issue to the operator SIG and GitHub you know, GitHub repo, and go forward from there.
That sounds excellent. Thank you very much.
Thank you. Any further parting thoughts? All right, so let me thank everybody. So I think the attendance have been really good. Thank you so much. I know also that some of you had to call in at difficult times, possibly from Europe or other places. So your dedication is much appreciated. And I think it has been nice to have a wide audience of people that can hear your proposals, and hopefully it's going to generate synergy between the different folks that do this kind of things, and go forward from there. So thank you so much, everybody. And I wish you a good rest of your day.
Thank you.
Bye.
Thank you very much. It was a pleasure. Bye-bye.
Bye-bye.